Welcome back to 6 Minute Math, where we turn confusion into clarity 6 minutes at a time. Thank you for joining us today for our topic on collecting like terms. 6 minutes does fly by, so here we go. Our key points when we are collecting like terms is to understand what like terms is. These are terms that have the same variable and exponent. This is best done with some examples. For instance, I have 3x squared and negative 5x squared. As you can see here, I have the same variable of x. Both of those x's have an exponent of 2. Even though the coefficient is different, these are like terms. If I look at another example, I do have a similar variable, y. Those y's both are squared. But in my first term here, I have an x attached. Because these two terms aren't exactly alike, they are unlike terms. Our two steps when we are collecting like terms is to first circle your separate terms to help us stay organized, and then we are going to add or subtract the like terms depending on the operation in front of that term. Please remember that that operation in front is attached to that specific term. Let's simplify by collecting like terms in the following example: 2x plus 3y minus 5x plus 4. I'm going to circle my like terms, and I'm actually going to use different colors to help distinguish between the two terms. My x's are going to be blue, and my y's are going to be red. As you can see, this minus 5x turns to a negative 5x as a single term because the operation in front is attached to that term. At this point, I'm going to collect my like terms. So 2x minus 5x is going to be negative 3x. I like to cancel off my terms as I collect them to again help me stay organized. Positive 3y plus 4y is positive 7y. This expression cannot be simplified any further as my x and my y are unlike terms. This is my final simplification. Another example here. I'm going to simplify by collecting the like terms in the following. Again, I'm going to use colors to help distinguish between my terms. So my x squareds are going to be blue, my x's are going to be red, and my constants are going to be green. As you can see with my circling, the operation in front was attached to each of those terms. We always start highest degree to lowest degree, so I'm going to start with my x squareds. 3x squared plus 2x squared is 5x squared. Negative 2x plus 5x is positive 3x. And lastly, positive 7 minus 10 is negative 3. Again, I do not have any unlike terms, or like terms, sorry, so I cannot simplify any further. Another example here. We're going to simplify by collecting. I'm actually going to use one color to circle all of my terms to make it more alike to what you would do when you're practicing. Again, I always start highest degree to lowest degree, so I'm going to start with my y squareds. Negative 5y squared plus 4y squared is negative y squared. 2x minus 2x. These are opposite terms, and opposite terms create a 0. I don't put the 0, so 2x minus 2x just cancel each other off. And then finally, positive 5 plus 7 is positive 12. One last example here. We're going to simplify by multiplying and then collecting like terms. We will need to use distributive property for this example. If you haven't seen the video on distributive property, please check out our video at 6 Minute Math to understand this example. I'm going to distribute my 3 into my brackets, and I'm going to distribute my x into the brackets. 3 times x squared is 3x squared. 3 times negative x is negative 3x. Plus x times 4x is 4x squared. And x times negative 2 is negative 2x. At this point, I don't have any more brackets, so I can circle my terms and collect the like ones. 3x squared plus 4x squared is 7x squared. Negative 3x minus 2x is negative 5x. Those are all the examples we have today for collecting like terms. Please follow us on Instagram and TikTok at 6 Minute Math, and be sure to like, share, subscribe, and leave a comment below for any topic you want to see me tackle in a future 6-minute episode. Always remember that the best way to get math is to practice math, so keep on practicing, and until next time, keep solving and evolving.